Okay, so we're on to 1.9, connecting multiple representation of limits. And this is kind of like the culmination of everything we've done from 1.1 to 1.9. And then the way the AP would test your knowledge on limits. Problem 1. Let G be a function that is increasing for x less than 1 and increasing for x greater than 1. Okay? If the limit as x approaches 1 of f of x is 5, which of the following could represent the following the function g? So they will give you a function representation in the algebra form. They might give you a table, and they might give you a graph. So you have to choose all of them. Either all of them are true, 1 is true, 2 or 3. It's just you gotta test each one of them. So let's take a possible answer 1. So it says that for x equal to 1, it is defined to be 3. There's nothing wrong with this statement here. Let's go with the limit. So in this one, let's find the limit as we approach from the left. And what we could do here is actually, we can start approaching from left to right. But now we actually can just do some algebra here. If we can somewhat get around this problem here, then we can just find the limit actually of it. So this factors out to be what, x and x, and then what, positive 4 minus 1. And we can cancel this out and substitute in. So here we can find the limit as x approaches 1 of the function, which is going to be x plus 4. Just plug it in and you get 5. So the limit as x approaches 1 is 5, satisfies this. So that would be an answer. That should be that satisfies it. That's a check here. This one. Let's go to number 2. The function is increasing. It is always increasing. Let G be a function that is increasing except add 1. It's always increasing. So as we go 25, 50, 100, if that is increasing. And on the left side, it's also increasing. Okay. No, it's on the left. Yes, let's see. On the left side is increasing. On the right side is increasing. Let's see. What else is this? What is the limit as we approach from the left? Let's see. As we approach from the left, right here, the limit's 5,000. It's getting closer to 5,000, or it's getting bigger. So as we get closer to 1, the output is getting bigger. And as we get closer from the right, the output is getting way negative. So it is defined to be at 1, 5. That satisfies what we have as a statement here. Oh no, it doesn't even matter. So this makes no sense. The limits, they're growing opposite. So this would not be a possible answer. Let's go to 3. As we get closer and closer to 1, the limit is 1, 2, 3, 4, 5. The limit is 5. It is an increasing function. It's going up for all values. This is going to satisfy it because the limit as x approaches 1 is 5. and it is an increasing function. So this one's going to satisfy the requirements. And so that's how we kind of attack these problems. So try this one. If h is a piecewise linear function such that lim x approaches 3 of h of x does not exist. So it does not exist. Which of following could represent the function h? This should be h then. Shouldn't be g. And this is a function h here. If h is a piecewise linear function, okay, which of one could represent function? So let's find the limit as we get closer from the left here. So we can just plug in lim x approaches 3 of 2x plus 1 and just plug in the number. The limit is 7. Let's do it from the right. The lim as x approaches 3 of 10 minus x. That would be 7. So the limit exists and the limit is 7, but it's saying that it does not exist. So this is not a possible answer. Let's go to 2. As we get closer and closer to 3, the limit seems to get closer to something like 6.8. And from the left there, and from the right, 3.1, it's 3.9. This one seems to be that the limit does not exist, but we're not very sure what's going to happen as we get closer to 2.99 and 3.001 if they actually do. But they seem to be that it's a limit that does not exist. So this one could be possible answer. Could be. Let's go to 3. As we come from the left, the limit is 7 from the left. And as we come from the right, the limit is 4. Definitely different limits. It does not exist. So this one also is a possible answer. Find the limit if it exists. If the limit does not exist, explain why. So these are like absolute value limits. So limits approaches 2 from the left of this absolute value of x minus 2 divided by x minus 2. We have to understand what an absolute value function is. So an absolute value function is absolute value of x is equal to x if for all values that are greater than 0. And it's going to equal to negative x for all values less than 0. So since we're coming from the left here, we're going to have to use this statement here. So it's going to equal to absolute value of x. Absolute value of x will equal to negative x. So we can go ahead and do that here. So the limit as x approaches 2 from the left is going to equal to negative x minus 2 over x minus 2. And we can cancel out x minus 2 and x minus 2. So the limit will be negative 1. Because that's what we left off only with. The limit is negative 1. Another way of looking at it is to choose numbers and plug them in and work them out, and it will still be negative 1. We'll do this one in a bit. Let's do number 5 here. This one is going to be this one right here. It'll equal to that for values that are greater than, because we're coming from the right. So this we can just simplify it as lim x approaches 2 from the right will equal to just that, x minus 2 over x minus 2, which cancels out, and the limit is positive 1. So now the limit as x approaches 2 would not exist because on the left is negative 1, on the right is positive 1. So it would not exist in these other graphs. Okay, we're done with this lesson. See you next time.